So before I start about today's session, so today we will learn about exceptions, we learn about use concept, we learn about Java generics, and then maybe if time permits, we will start rest assured basics, right? So any questions on yesterday's session? Type in the chat if you have any question. Okay, so let's proceed. Let's start with exceptions. So I created a class exception examples and one by one, let's see examples. Okay, so why do we need to learn exceptions? So there are many, as a tester, when you work on any application, you see a lot of exception lies in logs when you try to execute your test cases, something fails. So either exception comes in front end using, you get it using console, or if the exception comes in back end, you get it from the API, and then if you API exception is not clear, you go to the Linux server, go to the log file, look for the exception, and then you find it out, right? But many folks don't understand how these exceptions are generated. So when they work on automation project, especially when they join a new company and you try to recreate some of the cases or try to fix something, they they see these kind of exceptions. Now they don't understand why, how to fix those exceptions, right? Or why these exceptions are coming. So that's why it's important to learn about all these exceptions. So we will go one by one. So exceptions are two types: compile time and runtime. Okay. So compile time, it will ask you that throw the exception at compile time only. Means let's say you are opening a file, so you're supposed to give the file path. Now when you say file is equal to new file, then compiler will ask you please throw a file not found exception, because compiler know if you provide say wrong path, then it will throw a file not found exception. Runtime, so a exception like arithmetic exception where compiler does not. So basically what happens, let's say you wrote a division program A by B. Okay, now B and A values could be anything. Okay, an arithmetic exception divide by 0 will be thrown when B is equal to 0, right? So now in this case, compiler will not tell you that it will throw an exception, but during the runtime you get to know when you provide a 0 value. So if you provide any value greater than 0, it will work fine. But when you provide a 0 value, it will throw a arithmetic divide by 0 exception. So these exceptions are runtime, right? Now, as a tester, when you work on projects, be it a development project or your automation project, you see lot of exceptions examples. So we'll go one by one. So one is pretty clear, arithmetic, right? So let's say I have int a equal to something, int b, and then I try to print it a by b. Then what happens? Let's see. Okay, an arithmetic exception is thrown, right? So any math related exceptions are part of this exception. You generally don't see this exception when you work on your automation project or your project based on application, but when you're working with some statistics related project or math related project, you could see these kind of exceptions. Okay, let's talk about the second one, which is the most popular one, called null pointer exception. So as available by name, null pointer again, basically compiler will not know if you are providing a null values or not, right? So it will not ask you to like add try catch, okay, during compile time, but if it finds a null pointer exception at runtime, it will throw a null value exception. So basically, what when does this happens? So you define or declared a variable with null values, right? Generally, you declare a string with null. You perform some action on that string, and then you set it that value. Let's say you generated a variable with string result is equal to null, but now during the execution of program, you try to set the value result is equal to, let's say, char like get element text or get text, but due to some reason the element was not visible, or the element was not available, or the value was not available, you got null. Okay, so it remained null. Okay, but you are trying to now perform some action on that null value. Let's say you're trying to access the character 0, or the first index character of that particular string. Now because this value is null, you won't be able to extract the 0 index character. Okay, because null, there is no 0 character for a null value, right? So the example would be, let's say I say string a is equal to null. In those cases, to fix it, you need to debug properly and see if we are getting a null values while setting it up. Okay. So and now if I say so, let's say a dot char at 0, right? You got a null pointer exception. This is one such example, but you in application you would find a lot of exceptions related to this. What they are is either they are setting it to a value which is coming as null during runtime, or they initialize with a value and then the value would not set up during the execution. And now when they are trying to access it, they are getting a null value. So when they on this situation, you will get these null pointer exception. So one other popular one is array index out of bound, right? You would see a lot of time, especially when you are working as a manual tester and trying to debug issues or trying to find out the root cause. So what happens is, so developer has initialized an array. Now they, after initializing, put it some values there. Now during the runtime, they're trying to access, let's say, a value which is out of the range. Range is, let's say, if you added 5 elements, you're trying to access 6th element. Okay, so in those cases, it throws an array index out of bound because that index is actually not present, right? So something like that. So if I declare a array, let's say I say this arrays should be of length 5. Okay, and now I'm trying to set up a value at 6th location. Okay, so if I do something like that, a0 equal to 5, a 4 is equal to 6, it will work fine. But then as soon as I say a 6, exception would be thrown here, right? Again, this is because there was no compiler error shown. This is a runtime. Now I try to print it. Okay, array index out of bound exception. Because the length is 5, I'm trying to print a 6th element. Okay? So the valid indexes are 0 to 4, right? Even if I say 5, it will fail. But right, on similar concept, we also have string array index out of bound. So in that case, what happens? So we have a string of a particular length. Let's say I declare a string of let's say 10, length of 10, and then I try to access using caret or some values a value which is greater than 10 length, right? So something like that. It will, you will not see much because generally people does not declare and reuse that. But again, you should know this because in interview sometime people generally ask about different kinds of Java exceptions. So if I say so a dot caret, so I believe the length should of this should be 5, 6, 7, 6 to 8, 9, 5, 14, 20, 24. So if I say a caret 30 should fit. Okay. You could see that this time array is different. This is not array out of bound. This is string index out of bound, right? Because we are here working with a string, not an array. Okay. So once this is done, one of the other important one, and you could see this in automation as well as your application project, is number format exception, because we need to do lot of conversion from string to integer, right? So as clear by name, you're trying to convert a string in an integer, but you can only do that when a string is a equal or a valid number, right? If you want to convert a string which is not a valid number, then it will throw a number format exception because format is not correct, right? So let's say if I define this string as 5 and then try to print using conversion integer dot parseInt a, it would work because it is a valid number, right? But as soon as I say this is not a valid number because now the format is completely different. It does not have any valid number, so it will throw a number format exception. Okay, you could see this in application as well as in automation also. Generally also happens when trying to convert a null value to the parseInt, right? Okay, what else? The other part is input IO exception, right? File not found is again IO exception is input output exception, and if you make some mistake in input, inputting a file or inputting a user defined input, then you would see this error. File not found is one such exception. So if I say path name here, and if I provide a wrong path, let's say E, which is not present in my file system. Okay, and let's try to print it. We are not reading it. So FIS. Again, so as I asked, this is a compile time surrounds with. So there are two ways. Either you can do error wise, or you can add a throw declaration. So I'll add a throw this declaration. And now if I try to read this, let's see if I get some error. I could use a method, something like, okay, this file is not found. Okay, anything else in exceptions? One more thing is illegal argument. You'll see a lot of this in not on automation code, but in application, right? Uh, because developer has to. So what happens during negative testing when you running a negative test cases, especially on front end? Let's say there is a field which accept 10-digit number, but let's say you 10-digit positive number, you give numbers less than 10, more than 10, or negative numbers. In those cases they should throw that this is an illegal argument. You should provide a valid 10-digit number, right? Something like that. So how does developers handles it? So they basically, let's say I have a string number, and I would say if this number, right, dot length less than 10, or number, or I could just say not equal to 10, right? Not equal to 10, or number is less than 0. Okay, means if it is negative, do what? Do one thing. It is saying we need to convert this, right? Integer dot parsing. What? Throw illegal argument exception with a message. Okay, let's say you must provide number with 10 digits and more than positive digits only. Right? So this is how they got to know on UI that there is we need to provide a valid number. Okay, we do it as part of our negative testing, and you would see this sometimes in log and sometimes in API exception. Right? So yeah, this is about the exceptions. So whenever you work on something, make sure that it is throwing an exception, and you always add this in a try catch. So in Eclipse, you can do select the statement, then right click, and then surrounds with, and then try catch block. Always use that so that your execution, especially when you're running in a multi-threaded environment, does not stop when some of the test cases fail. Also, when something fails, you get the stack trace, means you get the where is this exception is happening. Any questions before we move to the next one? Type 2, if it is clear. I'm gonna give all this, so if you want to try it out, you can again try it out from code share. This is the URL. Any questions, guys? Yes, if you add an exception stack trace, you will get to know which method is throwing exception. Okay. So now here you would know everything, that why, how is the exception happening, where is the exception happening, and normally in stack trace you get all the information. That's why it's important to add this. Okay. So here you would know that this is the location where exception is happening. You would just click on this and it will take you there. Okay. And if you are working, so let's say if you are verifying in the report, so you would not know where to click on this, right? So in Eclipse you can type Control and L, and then type let's say here the line number is 24, so you can just type 24 and it will take you there. Okay, so if you are learning on local, you can just click on it, but if you are seeing something from remote execution, you would know that the exception is happening here. You would go to this particular class using Control Shift R in Eclipse. You would open this. Okay, here you would type the name of the class. So in our case, the name of the class is exception examples, right? Now you can open this class, and here you can type then Control L to go to the line number if you are coming from a remote execution error. Remote execution error, I mean when you are running something on Jenkins, etc., you saw the logs, there is an exception. How would you see that where it is in local? You come back to Eclipse, search for the class, then go to that particular line number. Control Shift R to search classes, and Control plus L to find line. Okay, any other question? Okay, so let's see a generics example. So generic are very important to learn for you. Otherwise, you keep on creating new methods. So generics are basically, rather than creating new methods based on parameter, based on data types, you create one method that can handle every data type, every return data type, and so on. Okay. So generally, when you create a method looks like this. Okay. So let's understand this. So this is like visibility. I'll talk about visibility later on in OOPS concepts. So basically, public means you can access it from anywhere. Protected means you can access within your child classes, and private mean you can access within your class only. Right. So, and this is the return type. Okay. So generally, if you don't want to return anything from the method, then it would be void, right? And if you want something from the method, let's say you perform some action and you want to get some data from Excel file. So you read that Excel file, go to that particular row, go to that particular column, fetch the value, then return the value to, so that you can use that in your test classes, right? So this is the return type. This is a method name. This is pretty clear. Now this is parameter. Okay. Let's say if you want to read something from Excel, you need, let me give you an Excel example. Get data from Excel, and here you would say string file path, right? So give me the file path, and now if I get the file path, I want the data after performing some action. So here I would say string result file path dot read. So I will talk about this when we talk about Hello library, right? Reading data from Excel. So something like that. We perform some action, got the value in result, and then we are returning a result, right? So the problem with this is, let's say sometime we need an integer value. Okay. Then how can, so I have to create a different method using polymorphism. Again, I will tell you about polymorphism later on. Polymorphism allows you to create different, like same form of same method but different form. So you would create one for integer, one for string, and so on, right? So when you want the result, so some, you have to do something like this. Right. So you have to create a lot of methods, because one method will give you the data from integer, one method will give you the data from string, and it will keep on adding if you have lot of. So this is what normally automation engineers do. They keep on adding click method, they keep on adding new methods, rather than making a generic method which can handle most of the stuff. Okay. One of the thing you need to do as an automation tester is write less code which can handle more and more logic. Okay. So this is where generic becomes very handy, right? So so generic methods looks like this. So instead of this, I could say public. The T could be anything. Okay, so don't go on this value. So return type I defined as a generic. So this could take integer, it could take string, could take anything, and this is return type is very important when we do rest assured, because in rest assured Sometime from JSON path, we would be extracting value from string or JSON string. Sometime from JSON path, we would be extracting field value of integer. Sometimes we'll be getting an array node, which would be a list. So that would change, right? Return type will always change. So instead of creating different methods based on different data return type, we would create one generic method there, and then that based on the return type, we can get the data in our test classes and perform actions on that. So we'll so save a lot of code there. So what I will say that give me a generic return type, okay, and so let's say get data or read data. Again, I could also say this also as a generic. So and then I could return param, okay, something like this. And now if I print it, let's remove this now. What's that? Oh, and if I create now, I give if I call this read data as a string, it will take the value. If I call it as an integer, it will take the it will return the value. If I call it as an float, it will return the value. If I call it as boolean, it will return the value. Okay. Let's see this if I do something like without this. Okay. What happens then? Then it will ask me to create this method, create this method, create this method, create this method. See, this is what I have to do if I had to do something like that. Okay, create 4 different methods. But with generics, I can achieve that within a single method. Okay. See, lot of people do that. They use object. So sometimes, so everything is here. If you supply an object also, let's say I create an object of some other class. It can take objects also. Okay. But if you're talking about something like that, like, so maybe you're talking about this, like, rather than a generic data type, you can use an object data type, right? So it can actually accept everything. A lot of people do that. So because object is a super class of everything, right? Something like this. See what happens in this case. Because system will show an error. Let me see. I can't print it. What can I see? Let's see this. Something like this will work. And I could say system cout object here. Right? You could do something like this also if you want to. But the problem with this, let's say when you do, let's say you have something like this, and you need to do a summation on that, right? And return the sum. Okay, so how would you do that? Because you can't perform operations on objects. Okay, object class, because that isn't data type. You are not supposed to do operations on that. This is where generics is more useful. In generics data type, you can perform actions also, right? So that is why you would see API actions class. I could show you. In one of my project. I wanted to wait for rest assured, but since you asked this question, something like this. Okay, so here the return type would be different. So if you replace this with my Eclipse stopped responding. So if you replace this with object, how would you take it when, let's say, you are reading it in your classes? Okay, because you can't do some actions on it, like some modification, some let's say you can't go add something you want to do. So let's say it returns a list. How would you say it object dot stream there? Because that would be a list. You can perform those action on a list. You can't do that on an object. Okay, so this is why you don't do that with object. So object has a different concept. When object is very useful, when, let's say when you are declaring some maps. Okay, so you can say a key could be string, but value could be an object. So it can take integer, it can take string, it can take list. That is a very good use case for object. But in generics, when you have to perform very like number of action, because in maps you just add element, that's it. You don't do any modifications or logical operations on that. But here in generics, you want to do some actions on that also. Let's say if you get a string, you want to do some indexing on that, or concatenation on that, and so on. So this is where generics are more useful. I hope it is clear. Let me go back to the previous thing now. This was the previous thing. No, this was the previous. Any other questions? Okay, let's move towards what? So exceptions are done, generics are done, hoops concepts, right? So hoops concept. So as a programmer, you could do everything in a single class. You could do everything without following principles. But then the problem with that is maintenance. The problem with that is code reusability. The problem with that is not having a structure in your project, right? So this is where OOPS comes handy. So object-oriented programming structure is defined to give you instructions. How would you uh, create code so that it is maintainable in future? How do you create code so that it is reusable in future? How would create code so that it has a structure that anyone can read it, anyone can perform actions on it? So it's just like gives you rules and directions, and if you follow them, you become a better programmer, right? So it has a concept of class, it has a concept of object, then it has a concept of polymorphism, then it has a concept of section, access modifiers, inheritance. I told you about these things yesterday also, like example wise. Okay, these are the main ones. There are many others like loose coupling and etc. These are the main ones. So how they help us? So class encapsulation is achievable through class. So class is an entity which binds variables and methods. Okay, and so what you do, you create classes based on your requirement. Okay, so rather than doing everything in one class, you create different classes, but their core structure is same, like one class where you need some. So let's say you're writing test cases for different modules, right? So you define everything related to one module in one class, then second module in second class, and so on. So everything which is like a slightly common, you try to bind it in a single class. If there are a lot of different attributes, then you create a separate class. So classes help you to bind lot of entity under bind similar kind of entity under a single entity. This is also encapsulation is that process. So you bind all those similar kind of entity under a single entity. So in class, you could have a logic, you could have variables, you could have methods, and then using object, you can access them outside your classes, right? So encapsulation is achievable through class. Object is basically you created a class and you binded everything, but how would you access it? So you access class members using object. Okay. Class also have one other thing called constructor. Okay. So let's say you add some variables or fields in class, but when you try to create an object, you want to initialize the values of those particular fields. How can you do that? So in those cases, constructor help you. Constructor initialize everything related to the class. Can initialize methods, it can initialize variables, can do lot of stuff. So rather than you do lot of stuff for each and every string or each and every variable and methods one by one, you could have everything under a constructor, and then when you call the constructor, everything will be initialized. You will use lot of constructor in our automation, especially UI automation, where we will try to send our driver object or initialize our base page class through a base test driver object. So we will send that driver as a parameter to the base page, and then base page will be initialized with lot of other weights and any other dependency related to the web driver. Okay, so let's see an examples now. Polymorphism is simple, many forms of same thing. You would see the example of this in lot of assert equals in TestNG, where you could assert equal on a boolean value, assert equal on a string value, assert equal on integer value. So it has like lot of forms of one particular method. Abstracting, hiding unnecessary info. Okay, so there are two ways to do that. One is abstract class, and the other one is interface. You use abstract class when you want like default functions for similar or for child classes or interrelated classes. So what we do in that, we declare the method without body, and then so this abstract class can have both abstract method and public other methods, abstract and non-abstract. Abstract is basically you declare method but not implementation, and you implement it in your child classes or extended classes. But abstraction is not limited to that. You can also declare and define everything inside abstract class for a non-abstract method also, right? But interface gives you 100% full abstraction. You can only have declaration there. That is the only declare methods, and implementation happens not in child classes, separate class. Okay, so if you need abstraction between interrelated class, you use abstract class. If you need abstraction between non-related classes, you use interface. Okay, interface also helps you in multiple inheritance. By default, Java supports single multi-level, but it does not support multiple inheritance. But through interface, you can achieve multiple inheritance. Like I can say class A implements interface 1, 2, right? Access modifier. So there are 3: private, protected, public. You use private for elements to hide within for elements to access within same class. Okay. So examples of this is fields. All the fields should be accessible directly, should be accessible within the same class only. Protected within child classes. Okay. Example of this, if you are using inheritance, you declare all those methods as protected. Okay. So in automation, example would be of this would be base test classes, base test and base page classes. Public, accessible from anywhere. Example of would be of this is utils, common reporting, anything which is accessible needs to access throughout the framework. Okay. Inheritance, pretty much clear. We will use lot of inheritance in our test classes, right? Every class will actually inherit or extend base class. Okay. So test classes also page classes in page object model, where every page class inherits base page. Okay. So this is like short description. Let's see the demo. Any questions? Type 3 guys, if you are with me. Okay. So let's say see a class demo. Let's say I have two fields, int age, string name. Okay. Always try to have these fields as private. Okay. Now create a getter and setters. You will see a lot of getter and setters in API automation in rest assured, where for deserialization and serialization purpose, we will create Pojo classes. And then for every JSON field, we will try to create getter and setter so that in runtime, if we need to get anything, we will get it. And if we in input, so basically in request, we will set all those value, and from response, we will get all those value. Okay, so serialization is sending in request, deserialization is and then converting from response to our get values using Pojo. We'll see a lot of that in rest assured. But if you need to create get and setter directly without creating like public void get name, public void get age, set similar to set things, you could do it. You going by source in here source, and here you would find a lot of stuff like it could create a constructor for you, right? And it could create a override implemented methods for you and generate getter and setters. So if I say this and select my fields, it would create getter and setter automatically. Okay, cool. So what we try to do is basically try to create these fields as private. and these getter setter as public or protected based on our requirement. So in case we need to access it from from classes which are not inherited or not part of inheritance, we declaring them as public. If we need to access it from child classes or inherited classes, then we declare it as a protected. Okay, so either you could set values like this. So what will happen? So now if I need to create a object of this class, so I will create a class demo object. Right now you would see I did not declare anything. So right now it is using default constructor, not a parameterized one. Default is basically an empty void constructor which is created by during compile time by Java. But when we say parameterize, we give parameters here, initialize the constructor in constructor, sorry, class, in class with the same name as class. I'll give you the demo about constructor also. So now if I need to access or set anything, so I could say class demo dot set age 29, and similarly then I would print value class demo get age. Okay, so this is how you can access public elements. So via this, what we are doing, we are accessing a public function or public method, but inside that we are accessing an age which is an in private entity. So I don't know about the private entity structure or the age field name or everything anything, but I could get the value using this particular method. So basically when you try to access something which are not related classes, you use objects. Okay, now if I had to do a constructor, basically constructor based demo, so there are two ways to do it. Either I could use getter and setters, or I could set this during initialization. So for that I would say public class demo, and here I'm expecting two things. And then I'm saying this dot age, set this dot age to the age which is supplied during object creation or object initialization. Similarly, set this dot name to the name parameter. Okay, change to a constructor. Now, if I access this from here, so it will throw an error because it needs. So let me add this in a comment. So this is an example of default constructor. And now let's see parameterize. We will use lot of parameterize in page object model. That's why I gave it. So it will ask me to declare these two values. So I would say 29 Chandan. Okay, and now because I don't need set methods now, because this is being set when during the object creation or object initialization, right? So I don't need this set age now. I could directly get age. Okay. Similarly, I could directly get name also. So this is how you use to set values. There are two ways. Either you use set as and public things, public constructor or default constructor, or you could use parameter constructor to set this during runtime, and then you would not need these setter methods. Okay, so I hope it is clear. Class and objects, right? Any questions on this? Type 4, if you're ready for next thing. Okay. So let's see a polymorphism demo. For that, I would need a test ng. So it's time we start test ng also. So I would replace this JUnit with test ng. Okay, guys. Okay. So let's see, like in this demo itself, if I have to verify the age is 29, how would I say assert equals? Okay. So now if you see assert equals, see there are a lot of options, right? The method name is same. So many forms of same thing. Method name is same, but there are a lot of option in terms of parameterization. Okay. So you could have polymorphism based on number of parameters, based on data types. Okay. So here you could see a polymorphism is being data type, some string, some short, some integer, and then number also. Boolean, string, three parameters. So this is like assert equals is the one of the good example, but in your code in test automation if needed. So let's say sometime you need to have a value which is, so let's say you created a method for get text. Okay. Now in future you need to change this or add get text or get the value of text when it is actually a label only. Okay. So you could add a flag that is label in extra parameter in extra method is label. Okay. Boolean is label. So in that case, when you need a a text of label, then you use get text of label. Otherwise, you would use normal get text. Okay. So, or if there are multiple parameters, sometimes you need to get text only if it is in string. Okay. Then you use that. Otherwise, if you need to convert, then you use get text integer. Right. So under that, you write a code for integer.parseInt. So you could do like, if you see this is an integer and this is a string, so assert equals one of them would be having a verification on string and the other one would be on integer, but the method name would be the same. See, it works for integer, it also works for string. Oh, now we are using not using JUnit, right? But JUnit is present in build path, so it will work for now. Okay. Okay. So now let's come towards the main topic, which is abstraction. So there are two ways to do it. Before abstraction, let's yeah, abstraction in abstraction only I will show the demo of inheritance. So there are two ways to do it, and interface and abstract classes. So let me give you an example of interface. So you can create interface by new and saying interface. Okay. So I could say driver interface. Okay. So you can create interface like that. So in interface, you only can have static, public static final values. Final keyword is when you use that with variables, it becomes a constant. When you use that with the method, then you can't override that method or change the properties of that method. When you use that with class, you can't inherit that class. Okay. Final means restricted. So restricted means you can't do any changes in that class or in that method or in that variable. So in interfaces, you can only have all those variables which are static final. So if you need something which can be changed in future, interface is not a good option. Okay. So let's say driver interface. What? So when we use driver, you would say driver opening is different from Chrome. Driver opening is different from for Firefox because the classes are different, internal interfaces are different. For Firefox, it would be Firefox driver. For Chrome, it would be Chrome driver. For Edge, it would be Edge driver, right? But what is the common thing in between these things is basically open browser and close browser, right? These two methods are common. So you can have wide open browser and you can have wide open, sorry, close browser. Now in future, any other driver is added, it will always have these two methods at least, right? So that's why I declare. So these are like universal things. Opening and closing browser will be there. So all those universal things you added in this interface, right? So when you work on interfaces, make sure you're working on those where you are sure that the in future things will not change. Because if anything changes in future, then you need to make changes in all the implemented classes. Okay, implemented classes where you write the definition of these methods. Okay, that's why if you see that there is a chance of changes in future, you use abstract classes because there you can use you can modify those in future and you can only modify one particular method which is being added. Okay, here if you make changes in future, let's say you add new method in future, you make have to make changes in all the implemented classes. So now let's say I create a implementer. So implemented class I can create and say driver implementation. And as soon as I say implements driver, it would throw an error and ask me to add the implementation, right? And now here I could add that this is a, so in the page object model, you would see a live example of this where we write the code for opening the Chrome browser. Chrome browser. Okay. Now you could easily create an object for this and use this, or inherit this class and use this. Okay. So abstraction. So an abstraction class. So when you say class, you can select abstraction. Okay, this is an abstract class. And as I said, base examples of this would be the base classes. So if I say base test, right? Why we creating as a base test as an abstract? Because we can, so abstract class can have common functionality for all the child elements. So this act as an parent class, and then all the common things you can add here which can be reused in your test methods, like test methods like opening browser, closing browser, uh, taking screenshot on failure, setting up all the objects, setting up page, initializing all the pages, all these things, or in API automation, setting up request specification, setting up response specification, all these things you can do in this class. Okay, so this is very important and will be used frequently in our framework, because this enables, uh, first of all, it enables hiding. So we show only the required thing, not the whole method. And then the second thing, it gives you the flexibility of code reusability. So you can use lot of code with this, because otherwise you have to add lot of things in everything. And the third thing is gives you is basically is prepare you for the future. So let's say I create a base test for web browser, right? I create a base test, and initially I thought that application will only be available for web. Okay, but in future what happens now, we also supporting mobile web. Okay, so basically on mobile devices also, mobile web browsers also. So now in that case I need to make certain changes in my opening web Chrome browser, right? So I could say in my other class, which is base web test, which extend base test, and I could say this overrides the create Chrome driver or create open Chrome browser method. And now it in the overriding part, I could say inside that method that add emulation, mobile emulation property, which was not needed in base web test, because in web I need like maximize view. In mobile web, I need an extra property called mobile emulation. Okay, so it enables you to prepare for the future also. So whenever you want to choose, so let me give you an example. So I could create all those methods here, like it supports those two methods. Like I said, it supports abstract method also. So in abstract method, you don't have to define body, right? You do it in child classes. So I will create a child class also. Let's say module one test, and it extends base test. Okay, as soon as I do that, it will ask me to add an implemented method. Now here I could define the abstract method definition, but it is only needed. So as I said, abstract class gives you both the functionality. It gives you functionality of hiding everything, or you could choose to add a non-abstract methods also, which is not possible in interface. So I could say in my base test, so this is not an extract method, and I could say So now here I would say protected, because I want these methods to be accessed via child classes only. Protected by open browser. Okay. Now if I go back to my child class, it would not need this method, because that is not a abstract method now. Now, but in future, if I want, let's say it becomes my mobile web test class, I could override this method. What's the name? Open browser. And now if I said that initially it was for web, later on when I got to know that it is available for mobile also, so it becomes mobile web. Okay. So which you can't do in interfaces. Interfaces, once you define that, you define that. Yeah, if you need to change it, then you need to change the overall structure. You cannot have same implement different implementation of one method inside one particular structure. Then if you wanted different implementation, you have to create a different implemented class, and then you have to refer that class going forward. Okay. So when to use abstract class and when to use interface. So abstract class is a good choice when we are using inheritance concept, because it provides a common code base for all the implementation to drive classes. Abstract is also good choice if we want to declare non-public members, right? Here we could say so here basically we have everything private or protected. In interfaces, if you need to use the values, if you need to use that values in implemented class, we need to have it as public, right? So here, if you need a lot of protection, you use abstract class. So other thing is, if you want to add new methods in future, then abstract class again is a better choice, because if we add a new feature in interface, then all the classes that already implemented that interface have to change. So if I created 3 implementation of one interface, I had to change all 3 implementation. Here, I don't have to do that. I will just add the method and I can reuse that. In base test class, I will add that method and I will use that in child classes whenever needed. Abstract class is also a good choice when we want different version or multiple version of same component. Okay, so in this case, just like I show you, I have a different version for web and different version for mobile web. Abstract class also have a good advantage of better compatibility, like in case something changes in future, if you use if you use abstract class, we can make changes inside that and use that. We don't have to do any changes in child classes. Interface, if something changes in future, so let's say this is my driver interface, and finally in future it needs an integer object or integer parameter, right? Now, if something like that happens, I need to change all my implementation again, right? So so the interface disadvantages is if anything added in current implementation, or if a new implementation is added, let's say void tear down. In both the cases, I had to change my all the implementation code. But in abstract classes, I don't have to do that. I can create a separate entity. I can create a separate class with object or parameter. I can create a new method, reuse that. I will not get an error in all my child classes. When to use interface? So interface is very useful, as we can say. Abstract class is useful when we are trying to work in interrelated classes or interrelated things, right? But interfaces are open to everyone, right? You can use interface, and then you can use those interface implementation inside your any test classes, inside your base classes. So they don't depend on each other. Okay, they are interrelated. They are not interrelated. Yeah, so interface is very useful when you're working with not non-related classes. Interface is also good choice when we know that something will not change in future. So if we know that this is not going to change in future and everything would remain like this, then you try to use that. Okay. So finally, I would say when we are designing a small and this functionality, we use interfaces. When we are designing a large functional testing suites or large large unit, then we use abstract classes. Any questions on that, guys? Today's class seems very boring, right? But for people who are new to programming, it is needed. Otherwise, you will be bombarded with a lot of these stuff in rest assured and Selenium and page object sessions. Type 5, if they are clear, everything is clear. So remember, these things may not be useful for now, but in interviews you can answer those things if somebody asks any questions. And also in future when we create frameworks, etc., we try to follow this approach: when to use interface, when to use so non-related stuff, interfaces, interrelated stuff, abstract classes. Okay, I think everything is done.